So welcome to this latest video 162 Maths, and in this video we'll be going over the GCSE Maths higher topic test on similar area and volume. Now as always, I'll include a copy of the questions that we go through in this video in a link in the description below for you to download and have an attempt at, and I'll also include videos that go through in more detail similar area and volume in the description below. Now before we get started working through some exam questions related to similar area and volume, let's just have a quick glance at some basic revision notes. Now the key thing to remember when working with similar area and volume is that if the length scale factor is k, then the area scale factor will be k squared and the volume scale factor will be k cubed. And remember that if you're working the area of a new shape, then you're going to need to know the area of the old shape and vice versa in order for you to work out what the answer is, and you need to be using the correct scale factor. Now the length scale factor is going to be different to the area scale factor, which is going to be different to the volume scale factor. Now a good top tip is that regardless of which lengths and areas or volumes you're given in a question, what you want to try and do is use whichever information you've got to work out what the length scale factor is and then go from there. So for example, if you know that the volume scale factor is, let's say, 8, well 8 is going to equal k cubed. So then to work out the length scale factor, which is going to be equal to k, then what I need to do to the 8 is cube root the 8, which will equal 2. And therefore the area scale factor is going to be k squared, which is going to be 4. So as you can see, then I've got three different numbers representing the scale factors for both volume, length and area. Now in more modern questions you might find that your scale factor is given as a ratio. So here you can see that triangles ABC and DEF, although it doesn't say that they're similar, we're going to assume that they are similar, and that the ratio is 2 to 5. Now we don't know the actual lengths, but I can use the ratio parts to work out the scale factor. So because these represent lengths, then to work out the length scale factor, which is equal to k, that's going to be the parts, which is going to be the length on DE, which is 5 parts, over the parts on the smaller shape, which is 2. So that means that k is going to be 5 over 2. So that means that the area scale factor is going to be 5 over 2 squared, which is 25 over 4. If I then, as a bonus, wanted to work out the volume scale factor, if it was a prism, then that would be 5 over 2 cubed, which would be 125 over 8. So now let's have a look at some exam questions. Now just a reminder, if you want access to these questions, all you need to do is just simply click on the link in the description below. And if you're not sure about this topic and you feel like what I just went through was a bit rushed, then obviously just click on the link in the description. I'll include where I've go through this as a lesson in a lot more detail. So looking at question 1a, it says the sides of an equilateral triangle are increased from 4 centimeters to 12 centimeters. How much bigger is the area in the new triangle? So here the length scale factor, which is k, is equal to 12 over 4, which is 3. So that means that the area scale factor is going to be 3 squared. So that means it's going to be 9 times bigger. It then says for B, the edges of a cube are all doubled in size. How much bigger is the volume of the new shape? So here, if the length scale factor is 2, then that means that the volume scale factor, because obviously 2 represents k, so the volume scale factor is k cubed, so that's going to be 2 cubed, which is 8. Then for question 2, it says A and B are similar cuboids. The surface area of cuboid A is 80 centimeters square. What is the surface area of cuboid B? So for this, first things first, what we need to do is we need to work out what the length scale factor is. So the length scale factor, which is k, and it could be any letter, you don't have to use k, but it's going to be 12 over 4.8. So that means that the area scale factor, which is k squared, is going to be 12 over 4.8 all squared. Now if I type that into my calculator, I get 12 divided by 4.8, which is 2.5, 2.5. square that, and I get 25 over 4, or as a decimal 6.25. So then to get from A to B, I need to multiply by the scale factor. So it's going to be 80 times 6.25, which gives me an answer of 500. Then moving on to question 3, it says that the solids A and B are similar. The volume of solid A is 432, and the question is asking me to work out the volume of B. So here the length scale factor is what I need to work out first, which is 24 over 12, and that's what K is, and that equals 2. So that means then that the volume scale factor, which is K cubed, is going to be equal to 2 cubed, which is 8. So then, as I'm going from small to big, I've got to multiply it by the scale factor. So the volume of B is going to be 432 multiplied by 8, which again, if it was on a non-calculator paper or a calculator paper, I'd have to work that out, but I get an answer of 3456. Then moving on to question 4, it says these two rectangles are similar, and it says work out the length of H. So here, the two bits of information I know on both rectangles is the area. So that means I can then work out what the area scale factor, which if you remember is K squared, that's going to be equal to 135 over 60. Now if I type that into my calculator, I get an answer of 9 over 4, which is 2.25. So K squared is 2.25. Now I want to know what the length is, so I want to know what K is, and K is my length scale factor. So then I square root 2.25, and I get an answer of 1.5. So then the length scale factor is 1.5. So then to work out H, I've got to go from the small shape to the big shape. So H equals 6 times the length scale factor, which is an answer of 9. Now again, if this was on non-calculator paper, I could just do 6 times and then 3 over 2, which is 18 over 2, which is 9. Then moving on to question 5, it says solids A and B are similar. The volume of solid A to the volume of solid B is 27 over 125. Work out the surface area, the ratio of the surface area of A to the surface area of B. So here, if I look at the volume scale factor, well, that's going to be 125 over 27. And that is what K cubed is. Now, one thing I noticed that these are both cube numbers, so therefore the length scale factor is going to be the cube root of 125 over 27. And the cube root of 125 is 5. The cube root of 27 is 3. So then I can then work out what the area scale factor, and that's what K is. So then the area scale factor, which is K squared, so that's going to be 5 over 3 squared. 5 squared is 25, and 3 squared is 9. And obviously because A is smaller than B, I just need to change those around, so it's going to be 9 to 25. Then moving on to question 6, it says P and Q are similar solid cones. The base of area of P to the area of Q is 36 to 625. Complete these ratios. So here we know that the area scale factor, which is K squared, is going to be equal to 625 over 36. So then to work out the length scale factor, which is K, I need to square root both those two numbers. And the square root of 625 is 25, and the square root of 36 is 6. So then the length of this is going to be, well, P is smaller, so it's going to be 6 to 25. And then using this, that if the length, so if K equals 25 over 6, then K cubed is going to be 25 cubed over 6 cubed. and 25 cubed is 15625, and 6 cubed is 216. Now moving on to question 7, it says two shipping containers are similar in shape. The scale factor of the enlargement is 1.5. The smaller container has a mass of 1.8 tons. Work out the mass of the larger container. Now for this, because we're dealing with mass is to do with capacity, which is to do with volume. So here we know that the length scale factor is 1.5. So that means that the volume scale factor is going to be 1.5 cubed. So then to find the mass of the larger container, it's going to be 1.8 multiplied by 1.5 cubed, and if I type that all into my calculator, I get an answer of 6.075 tons. So moving on to question 8, it says P and Q are similar cones. The volume of P is 312.5 and the volume of Q is 20. Work out the ratio of the base radius of P to the base radius of Q. Give your answer in its simplest form. Now this is, although it's talking about the base, it's talking about the radius, so that wants me to work out the length, and this is also length, and here I've been given the volume. So here, working out the volume scale factor, which is K cubed, that's going to be equal to 312.5 divided by 20. Now if I type that into my calculator, I get an answer of 125 over 8, which as a decimal is 15.625. Now that's what K cubed is. So if K cubed is 15.625, then K is going to equal the cube root of 15.625, which on the calculator gives me an answer of 2.5. Then from this, what I then want to do is write this as a fraction, so that is 5 over 2. So then looking at this, if the fraction is 5 over 2, I then want to convert that into a ratio. I know that P is bigger than Q, so it's going to be 5 to 2. Then moving on to our last question, it says X and Y are similar prisms. The area of the length of X is 6. The volume of Y is 1125, and the question's saying that the ratio of the area of X to the area of Y is in the ratio 4 to 25, and the question's asking us to work out the cross-sectional area of X. So let's have a look at what we've got. So using this, I can then work out what the area scale factor is, which is 25 over 4. Now from this, I can then work out that the length scale factor is going to be the square root of 25 over 4, which is 5 over 2. And I can then work out what the volume scale factor is, which is 5 over 2, or cubed, which is 125 over 8. So let me just start by writing that up a little bit neater. So the length scale factor is 5 over 2. The area scale factor is 25 over 4, and the volume scale factor is 125 over 8. So then what I can do is then work this out. So if this is 6, to work out this length here, I've got to do 6 times 5 over 2, which gives me the answer of 15. Now if I know that the volume of Y, I can then work out what the volume of X is going to be by doing 1125 divided by 125 over 8. So 1125 divided by 125 over 8 gives me a volume of 72. Now to work out the cross-sectional area of X, which is what I'm wanting here, now to work out the volume of X, it's the cross-section multiplied by the length. Now I know that the length is 6 and this is what I want, and I know that the volume is 72. So here then what I've got is 72 equals, and if I just call this x, times 6, so then x is going to be 72 divided by 6, which gives me an answer of 12. So the answer then is 12 centimetres square.